Similar to multiplying by our radicals, okay, we have a quotient rule. So our product rule was square root of A times square root of B equals the square root of A times B. That's what we worked with on Thursday, okay? Now, if we have the square root of A divided by B, it is the same thing as taking the square root of A divided by the square root of B, okay? So those can be interchangeable. Okay, now here is where things get kind of weird. Look for our perfect square radicals to simplify. Okay, we need to simplify any of our radicands, and we need to make sure that our coefficients. What's your problem? We need to make sure that our coefficients are simplified once we get all of the radicals simplified. Okay, and I'll show you what I mean here shortly. Okay, we're going to start really easy. Okay, the square root of 49 over the square root of 100. Okay, so when we have division under our radical, we can break this apart into the square root of 7, excuse me, the square root of 49 divided by the square root of 100. If we have division under our radical, we can break it apart into the division of 2 radicals. Why is this helpful? What's the square root of 49, Connor?
7, but do you like keep it in the square root so you just write it as a fraction?
What?
You just write it as a fraction.
Yeah, so 7 over what's the square root of 100? Yeah. Yes. We'll get there. We'll get there. Did you have a question? Did you have a question? Okay. Now, we do not have perfect squares in number 2. Okay. But what we have is we have the square root of 8 over the square root of 32. What do we need to do with each of those? We need to simplify them. So we know what perfect square divides into 8. 4 times 2, right? Okay. What about 32?
16 times 2.
16 times 2. Okay. So our numerator becomes 2 square root 2. Our denominator becomes 4 square root 2. That is not it. Ellery says, oh, our answer is 1/2. Who can explain how Ellery got 1/2? Because she's right. Brooks?
The squares are the same, and you have simplify. Oh no, the squares like the.
So square root of 2 divided by square root of 2 is 1. Square root of 16 is 4. Okay, so Brooks, in a roundabout way of saying that the square root of 2 over the square root of 2, those are going to cancel each other out. And we have left with 2 over 4. Hey, what's 2 over 4? Good job, Ellery. I think I said Ellery. All right. How about this one? The square root of 3/16. We can break this apart into the square root of 3 divided by the square root of 16. Can I do anything with the numerator? No. So what's our denominator? 4. Just 4. So the square root of 3 over 4. What don't you get? Well, do we have something that can reduce square root of 3? So it just stays as the square root of 3. But we know that the square root of 16 is 4.
Yeah, but like you didn't do that on the last one.
We actually did. But we had to reduce both of them. The way the problem was, my numerator was square root of 3. I can't reduce square root of 3 no matter how hard I try. But we could reduce the square root of 8. What's that gonna do for you, Zayden?
Wait, so theoretically, if you put 3 times 1 and 8 times, oh no, 1.5 times 2 and 8 times 2. I basically used something in the last one. Making it as a 2.
No. Hey, how about you guys do number 4? Yeah.
I have a question about square root of 7 over 7.
Yep, that's it.
Thanks for it's really easy. You would have gone to wait, I'm home.
Wait, what?
No. Well, square root over square root of be divided by 1.
And Miss Notes? Yeah, that's fine. Okay. I said yes. Zayden, what did you get for number 4? Radical 7 over 7. Good. Now, I want to show you that it doesn't have to be work with the numerator separately, work with the denominator separately. So I want to show you something we can do here, okay? The square root of 10 divided by the square root of 45. So we could do this. We could say, oh, hey, this is the square root of 10 over 45. That is okay. And 10 over 45 is a fraction that we can simplify. What would we simplify it to?
2 over 9.
Okay, now why was that helpful? Because now we can say, oh, hey, this is the square root of 2 over the square root of 9. And we know that the square root of 9 is 3.
So you have all the problems.
If it's to your advantage, yeah. Now,
This is gonna be the advantage of everybody.
I disagree, because look at number 6. Look at number 6. I don't think it would be an advantage to do that on number 6, because what's your denominator?
Well, square root of 12.
No, that's 1/3.
Okay, 36 is a perfect square. So I don't think it would be helpful to reduce our fraction of 12 over 36, because I know that the square root of 36 is 6. It is?
No, it's still radical 3.
So it's 12 is 4 times 3, right?
Why is that faster? The other one, no, normal.
Now, is this fraction reduced? Two over 6 can be reduced to 1/3. Do you have to write the 1? No. Can you write the 1? Sure. Sure. Okay. Now, if you don't like this method of putting them both under the radical to simplify, that's okay. You're still going to be able to get to the same place. Sometimes it can save you time. Okay. Like look at number 7. If we put these under the same radical, can we take 96 divided by 3? What is it?
No.
Okay. And now we have a super simple problem. The square root of 32, does it have a perfect square?
Yes.
Yeah. So, now, here's the deal. Some of you are like, ooh, I can get around some things. I have some shortcuts that I can use, but here's the deal. We are not allowed to leave a radical in our denominator. Okay, so I want you to flip to the next page. That's
Wait, you're not allowed to leave a radical in the denominator?
hold on. Like, do you see this? 4 over radical 7. This is not simplified. Okay, to be fully simplified, we have no radical left in the denominator. None. So if we have a radical in the denominator, then we have to do a process called rationalizing the denominator. This means we are going to take whatever square root is in the denominator, and we are going to multiply both the numerator and the denominator by that square root. Okay, so let's go to Kari's question. If I have the square root of 3 times the square root of 3, what is that? Which is? So the whole purpose of multiplying both numerator and denominator by that radical is to create an integer for our denominator. Okay, so let's start with number 13. Is this simplified? No, we already said that because we have the square root of 7 in the denominator. So if you have a square root in the denominator, take that square root, and we are going to multiply that square root to both the denominator and the numerator. So what's 4 times square root of 7? 4 times the square root of 7. Kyron, the 4 is not under the radical, so we can't multiply it to the 7 that's under the radical. Okay. Now, in the denominator, what's the square root of 7 times the square root of 7?
What?
Square root of 49, which is 7. And do you want me to write, this is the square root of 49. So we have 4 square root 7 over 7.
Wish I was a 7.
You ask.
I said 7. Not 7.
Okay, Allison just asked, how do we know when to do that? If we have a square root in the denominator, and we can't do any simplifying there, we got to multiply by that square root. Okay. Yes. Like, are you saying like the square root of 15/3, like that? No. Because the 3 is not under a radical. If it was like this, then you could. Okay. All right, so let's look at number 14. Okay, so would it be helpful to write this as the square root of 5 divided by 2? Is there any simplifying we could do with that? No, not going to help us. But we have the square root of 2 in our denominator. We cannot have that, okay? So we are going to multiply both numerator and denominator by that square root of 2. This is ruining my marker. Didn't sharpen.
I tried sharpening it, but it doesn't.
What's in our numerator? Do you agree with Henry? Square root of 10? Square root of 10. What about our denominator? Square root of 4, which is 2. We cannot simplify this any further. Square root of 10 is just the square root of 10. Okay. Now, sometimes we need to work smarter and not harder. Okay. You need to look for opportunities where things are going to be helpful. Okay. Over here. Oh man, can we take 81 divided by 2? What are we gonna do?
Yeah, square root of 81 over square root of 2.
Okay.
Times my square root of 2.
So hold on, don't get too ahead of yourself. Yes, I understand that we can't have a radical 2 in our denominator, but let's slow our roll. In our numerator, can we do something to help us?
Divided by 9.
Okay, we're not dividing by 9.
Divided by 9.
This, let's reduce the square root of 81 to be, so we have 9 over radical 2. It's going to be much easier to rationalize our denominator if we've simplified the numerator. Okay, so now we can't have radical 2 in the denominator. Aren't you glad we don't have to take 81 times 2 and then simplify that?
Radical 18 over radical.
No.
No,
9 times square root of 2 is 9 radical 2. Okay. And then in our denominator, radical 2 times radical 2 is radical 4, which I'm going to just write as 2.
Don't you?
Okay. Now, can I reduce 9 over 2?
Yeah.
I can reduce 9 over 2? No. If this were like 8 over 2, then we could simplify it, but it's 9 over 2. Okay, I want you to try number 17. You try it. You're lost? Nope. I heard you say you're lost. Yeah. Sure would.
I think that's the answer, right?
That's the answer. elbow partner, make sure you have the same thing.
I'll wait for you, don't you worry.
Not reduced, not reduced, not reduced. So you need to multiply by radical 2 over radical 2. Since radical 2 is our denominator, we're gonna have to multiply by radical 2, radical 2. No. Yes. Okay, if you have the answer of 2 radical 6, you are right.
What?
You're kidding me?
Okay, don't erase everything. I have some people who didn't simplify. So your first step needed to be to multiply numerator and denominator by radical 2. Were you good there? Yeah. When you do that, you get 4 radical 6 over 2. People. What's 4 divided by 2? 4 divided by 2 is 2. So we got to simplify to that. Okay. So if you got to here, good job. That's the hardest part. Byron. They're all looking at you. I don't know. That's what I'm wondering. Turn around. Okay. All right. Let's do number 18 and then we'll get you to your homework. Okay. I'll wait for you. Okay. Any suggestions on what to do first? Kari. Okay. Is everybody okay with that first step? Multiply radical 3. Okay. Oh, what did you say, Ellery? The square root of 4 is what? Is 2. Now let's talk about multiplying by that square root of 3. Okay, so what we have, okay, we took square root of 4, we changed it to 2. Now we have a square root of 3 in the denominator. So now we're going to rationalize our denominator. In our numerator, we have 2 radical 3. But what do we have in our denominator? How'd you get that? Okay, so radical 3 times radical 3 is radical 9, which is 3. And 10 times 3 is 30. Yes. It can be simplified. What can we simplify? Oh, yeah. So 2 over 30. Where does the 15 go? Yeah. Yeah. So 2 over 30. Those are both divisible by 2. So 2 divided by 2 gives us 1, and 30 divided by 2 gives us 15. Right? Yeah. Okay. Okay, so I want to give you a chance to start this in class, just in case you have some pickups. We're on page 14 and 15. So I'm going to ask you to do only the odds from page 14 to 15. Only the odds.